The investments being celebrated today are examples of how our government is building our country's research capacity and investing in our economy. We're helping colleges and universities undertake cutting-edge initiatives that will strengthen our position as a research leader.
We are determined to be part of the solution to meet our challenges and turn these challenges into opportunities. And I cannot think of a better way than creating a CREATE program that will address two things at once. Growing number of our students, they have built tremendous confidence throughout their studies here that they have either started their own business, their own company, or they're entering into doing something very meaningful to this economy, to Canada. And we'd like to see this confidence, together with their competence, growing further.
Our government continues to invest, and we do that, ladies and gentlemen, because we know that the next generation of scientists, of researchers and innovators are those people who will look beyond the immediate challenges that the nation faces to the endless possibilities that are out there. So we achieve this goal, ladies and gentlemen, through a number of initiatives. One, of course, is by investing in the Collaborative Research and Training Experience Program, or CREATE. Here at the University of Waterloo, again, of course that's why we're here this morning, is to announce that 2 recipients will share $3.3 million through this program. First, Dr. David Corey, who is with us this morning, who, by the way, is also a Canada Excellence Research Chair in Quantum Information Processing, will help train graduate students, postdoctoral fellows, and undergraduates in this cutting field. As well, Dr. Muska, through mentorship, cross-disciplinary collaborations, and partnerships with industry and government, will train the next generation of highly qualified personnel in the field of quantum cryptography. Congratulations to all the recipients on the CREATE program, and in particular to those here at the University of Waterloo.
My CREATE colleagues and I, we do research in cryptography. This is a foundational pillar of information security and at the core of information and communication technologies. Essentially, you can't have a functioning internet without cryptography. Since quantum technologies are already here and growing, we need to guarantee secure, reliable cryptography in this quantum future that we're creating. The current cryptographic infrastructure is simply not viable, simply won't work, as it currently does, in a future with large-scale quantum computers. And we can't just sit and wait for our colleagues to build these large-scale quantum computers, because it's also going to take many years to design and deploy the next generation cryptographic infrastructure that will be safe against these future technologies. So we need to start now. Now, this might seem worrisome, but in fact it's very exciting because it opens up a tremendous opportunity for us. We now have an opportunity to position Canada to be the world leader in the next generation cryptographic infrastructure, to be the global supplier of the new solutions. The CREATE program challenges us to think deeply about what can we do, about what we can do to better prepare our students to make a positive, productive impact in the workforce after they complete their work here at IQC or at the Centre for Applied Cryptographic Research or with our colleagues in Montreal and Calgary. This program will enable our graduates to meet these critical challenges and be at the forefront of using their scientific and technical skills to create value and prosperity for our society. On behalf of all of us, we thank NSERC and the Government of Canada for believing in and supporting these bold and important initiatives.
Okay, thank you. Let me share with you a vision of this CREATE program. We're going to take ideas of quantum information science, we're going to take ideas of neutron physics, and we're going to combine them in such a way that at the interface of those two, we get out of the lab and do something important to society. So how do we do that? Well, quantum information is at the foundation of measurements. If you want to make a precise measurement, you need to come to quantum information. If you want to make a precise measurement of something small, you can't neglect quantum information. And neutrons, they're really small. So what the program do? The program will create a cohort of young, uniquely skilled, multidisciplinary researchers. And this training program, this is the best place in the world to do it. It builds on the long-standing reputation in neutron physics that was developed at McMaster and the Brockhaus Institute. It builds on the excellence of quantum information that's contained here. I mean, it's all you people at the University of Waterloo and the Institute for Quantum Computing. And it looks to apply these with our partner, NIST, the National Institute of Science and Technology in the United States. NIST is a wonderful collaborator. Not only does it have great and unique facilities, it has a wonderful staff of science and engineers, and they share our vision, and they support our vision, right? They're funding the development of these machines. But it's also the mecca for industry. You come from industry, you want to make a precise measurement, you go to NIST. You want to know what the future is, you go to NIST. You have a problem, Ford, our collaborator, working on batteries. They want to know what's happening at the membrane. They come to NIST, and what are they going to find when they come to NIST? They're going to find our students building the next methods. They're going to work side by side with our students to take the methods that they develop using quantum information processing and neutron physics and translate that into applications that are broadly useful. So, this is only possible for things like the CREATE. So I thank you and you for your support of this. And I look forward to seeing how it all happens. So thank you very much.